Let's go ahead and take a look at another example. So in this case, we're going to have this alkene. And then later on, we're going to transform it into this alkyne right here, right? So naturally, we want to go through our questions. One, did the number of carbons change? So we've got this kind of isopropyl group here, this kind of isopropyl group here. I'm just going to count from the alkene, 1, 2, 3, 1, 2, 3, 4, 5, 6, right? So it obviously did change. If you want to count those methyl groups, you totally can. You can make up your own arbitrary counting system. It doesn't really matter. And so in this case, we said, yes, we did add some alkenes. In this case, we added 3 carbons, right? So maybe some kind of acetylide anion got added. And so if we think about that and do the retrosynthesis, what would we have needed for that retrosynthesis, right? We need our 3 carbon acetylide ion, and then we need to make the rest of this carbon have some sort of halogen group on it. So something like that, right? That'll take care of the rest of this component, right? You can see these 3 carbons in the isopropyl came from right there. And then we've got 3 more carbons here, 3 more carbons right here. And so now we've got to go ahead and continue and linking these things together. And so maybe another question that we want to ask ourselves is, what functional groups changed and did they move, right? And the answer is yes, they did change. We went from an alkene to an alkyl halide, and it moved. Right, it moved positions. So when we're thinking about moving these positions, we can think about these successive addition-elimination reactions. So over here, starting at this alkene, we can move our bromine towards the less substituted position because eventually we're going to want a primary alkyl halide. So we can add some HBr and ROR. Right, and then we can go ahead, continue on, right? We want to move our alkene now, do this elimination towards the less substituted position. So we need some kind of bulky base, maybe like a DBU, to make this alkene right here. And then finally, how can we link these two? Well, we can link these through an HBr and an ROR, right? So you can see how if you work backwards and then work forwards a little bit, you can meet in the middle with the correct answer. Of course, there are multiple ways to do any one of these problems. So if you find up a good synthesis as well, and you want to double check it, just let me know.